Hello, my name is Reese Allen. This is my Lab 2 final submission. So Lab 2 is very similar to Lab 1 in that the first half of the experiment was about the same. So initially there's a physical part of the experiment. It mainly deals with electric forces and gravitational forces. So at the beginning you focus on how charges and how objects that are charged affect neutral objects. And then the lab begins to shift to comparing two similarly charged pieces of tape, and the tapes are used in an experiment to calculate the charge of each tape, as well as many other calculations. This experiment varies from Lab 1, in which the model, instead of using single point charges of each tape, we use a line of charge. So to run back through the main points and calculations of the first half of the experiment as a reminder from Lab 1, we saw that a U-tape, which we don't know the charge of yet, was attracted to a neutrally charged hand, and then that two U-tapes placed in each other repelled one another. And then when placing a negatively charged pin near one of the U-tapes, it proved that the tape had a positive charge as they attracted one another. So then as you start working out the calculations, you find that the gravitational force on the upper tape was 1.96 times 10 to the negative 3 newtons, which is just mass times gravity. And then at a point found, which was 3.87 centimeters below this tape, the lower U-tape begins to push the top tape up, meaning that at this point, the gravitational force and the electric force should cancel out. So when you solve for this equation for charge, it results in a charge of 1.806 times 10 to the negative 8 newtons, and that was the charge of one piece of tape. This total charge divided by a single electron's charge gives 1.13 times 10 to the 11 electrons, and that is in deficiency, creating a positive charge. And then I found the total number of atoms on the piece of tape by finding the length and width of the tape, multiplying by an atom constant, which was 1 times e to the negative 10, or 1 e to the negative 10, which is per meter. And then a ratio of excess electrons to atoms was just the total electrons in deficiency divided by the total atoms on the tape. So the main way this lab differs from Lab 1 is in the modeling portion or the coding portion. I have my link to GlowScript right here to show my code, and then it kind of begins as filling in constants into the skeleton code. So I started filling in mass, PHYS, length and width, the scale factor for the arrows of both forces, and the distance between the tapes. And then I listed charge of one piece of tape here, but that would eventually change. That was just a guess at first. But we would rearrange this number to find out what charge needed to be on the bottom piece of tape to equal out the forces of gravity and the electric force. So I changed the n value to 15 spheres per tape, which are individual points on the line of charge. And by evaluating different overall charges, which is the change I was speaking of a second ago, I found that the charge of 1 times 10 to the negative 11 newtons balanced the gravitational force with the electric force. And by the green arrows were placed to represent each respective point. Each respective point charge, there should be 15 of those. And then the larger arrows represent the total gravitational and electric forces. Gravitational being the yellow and electric being the white. After finishing the lab, you can see that a smaller charge is actually held by each tape. What if you had modeled each of your tapes as a single point charge like the previous lab? Compare the estimated value of the charge you get when your experimental data to produce a point charge model to the value you got with the line charge model. So this question was a post-lab question, and it really is just trying to get us to compare Lab 1 and Lab 2. Had I used a single point charge, the result would have been very similar to Lab 1's findings, where we found a charge of 1.806 times 10 to the negative 8 newtons, and that was a charge of a single piece of tape. And then using this second model, I found the charge of each piece of tape to be 1 times 10 to the negative 11, which is about 3 magnitudes smaller. Why do these estimates differ, and which value is more likely to be closer to the real value, and why? These estimates really differ because the line charge model works as many point charges that relate to a distributed charge over a distributed piece of the line tape, rather than where the point charge model puts all the charge at the center of the piece of tape. So the line charge method actually is much more accurate, as it more closely identifies approximate charge as the number of point charges increase. So the more point charges you have, and the better the charge is distributed, and the better the location works to get a more accurate representation of the charge.